Hi, good morning everyone. So today I would like to take this opportunity to present to you all our project entitled AM Transmitter and Receiver. We are from the group 4 and our lecturer is Dr. Shaharil bin Muhammad Shah. So first I will introduce to you all our team leader Tan Jin Sian, followed by me, myself, Lim Jen Siu, followed by Nurul Aini, Nur Shafika, Kelvin Wong, and lastly Aswadi. So right now I will pass to my teammates Aswadi to continue the introduction.
So thank you, Gerald. My name is Muhammad Aswadi bin Saidin and I'm going to talk about our project background. So our projects need us to construct the transmitter and also receiver of AM modulation. AM is some kind of modulation technique for information transmission via radio transmission. So AM, this kind of method is first introduced by a Canadian engineer named Reginald Fessenden in 1901. For AM modulation transmission, we're going to need two main components, which is a transmitter and a receiver. Generally, a transmitter is a component that we use to transmit the information signal that we want to transmit, and then the receiver are going to capture the radio wave transmitted by the transmitter and then demodulate the radio wave so that we can play it on the speaker. So next is I'm going to proceed with the objective of this project. Objective. The first objective is we're going to design the transmitter and receiver that can transmitting and capturing the signal at frequency band of 5 to 5 kHz until 1705 kHz. Second one is we're going to apply the prototype design on the PCB board. So next is the project scope of this project. We derive the scope is based on the objective that I have presented earlier. The first scope is to design the circuitry of transmitter to transmitter circuit, and the second scope is to design the circuitry of the receiver circuit. And then we apply both of the circuits on PCB. The last one is to demonstrate the prototype so that we can show that it can work perfectly. Thank you. So I'm going to pass this to Nuraini.
Thank you, Aswadi. Assalamualaikum and good morning. I am Nurul Aini and I will talk about the proposed system block diagram of AM transmitter. As we can see here, the oscillator will carry signal which lie in radio frequency range, and as we know, the frequency carrier is always high. As for the buffer amplifier, its function has two folds. The first one has the output impedance of carrier oscillator and with the input impedance of frequency multiplier. And the next stage, it will isolate the carrier amplifier, carrier oscillator and frequency multiplier. For the power amplifier, the power of carrier signal is then amplified in here. This is the basic requirement of transmitter to give high power current pulses of carrier signal at its output. For this part, the audio signal to be transmitted is obtained from the microphone. The audio driver amplifier amplify the voltage of the signal. This is necessary to drive audio power amplifier. And for the modulator, this is the output stage of the transmitter. The modulating audio signal and carry signal after power amplification applied to this modulating stage. From here we can see the power supply will go to the modulator and go to the power amplifier and antenna. So that's all from me. I will pass to Syafiqah.
Okay, thank you, Aini. Assalamualaikum and good morning. I'm Syafiqah Muhammad Yusof. Today I will continue our presentation about block diagram AM receiver. First, for the signal to RF amplifier. RF amplifier can selected desired station from the menu. RF amplifier, it is adjustable. The frequency adjustable. The selection frequency can be altered. This is called the tuning. From the RF amplifier to the mixer, the output local oscillator go to the mixer, reply to the mixer, and the mixer and the output local oscillator form a frequency charge circuit. IF frequency are fixed frequency, it is 455 kHz. For the mixer to the IF amplifier, it is have advantage for IF amplifier. It's a frequency and the bandwidth is fixed. So this make design and the operation of the amplifier is more simple. From the IF amplifier to the detector, IF amplifier signal feed to the detector. So this circuit, this card recover the audio signal and discard and discard of carrier. Some of the audio go back to the IF amplifier as the automatic gain control voltage. After that, the detector go to the AF amplifier to the speaker. It is ensure that when the turning from the weak station to the strong station, loudness of the loudspeaker stay the same. Thank you for me, and I will give to the link.
Okay, thank you, Syafiqah. So, my name is Lim Jian Siu. So, I will present to you all the first proposed circuit, which is the transmitter one. So, as you can see, this is the PCB circuit that we made from the diagram beside them. So, basically, this circuit contains two important parts, which is the first part will be the audio amplifier, and the second part will be the radio frequency oscillator. So, as you can see, the Q1 is actually built surrounded the Q1 BC109 and surrounded by the related component also. So, this circuit is actually tunable between the range of the 500 kHz until the 1600 kHz. And as you can see, the Q1 is actually used to provide the regenerative feedback for the circuits, and the Q2 is actually to ensure the oscillation is transferred from the collector, then go to the emitter, back to the base again. And the R7 is actually used for the make sure the oscillation will not be shunted again to the ground to a very low voltage. And basically this is the end of the part for the transmitter one. And next I will continue for the AM receiver number 1. So this is the PCB circuit that we made from this diagram also. And basically this circuit is actually tunable from between the range of the 550 Hz and to 1100 kHz. So the Q1 is actually the emitter follower, and the Q2 is the common emitter amplifier. So the function of the Q1 is to prevent the loading of the tank circuit, and the Q2 is actually to use for the voltage gain for the whole circuit. So as you can see, the L1 and the C2, we actually use the L1 and the C2, the combination with the R6 and the R7 to perform the regenerative feedback for the whole circuit. And you back to the Q3, the Q3 is used to perform the demodulation of the carrier signal. And lastly, the C6 is to provide some of the noise filtering for the whole circuit. Okay, this is the end of my part. So next I will pass to Tan to continue for the transmitter and receiver too. Thank you.
Thank you, Jaren. Now I will proceed with my part. This is the proposed circuit, the transmission for the second circuit. this PCB is reviewed from this circuit. Okay, first of all, this is the transmission circuit. We're using two transistors, which is the 2N22222A. This transistor actually functions as a pre-amplifier from the microphone, and the second transistor is for the oscillator, which for the carrier signal for transmit the RF signal. Okay, as you can see, there are two tune circuit. This tune circuit, the inductor and the capacitor actually is to control the frequency of the second transistor, and these two, the inductor and the capacitor, actually is to match the frequency from the oscillator for the transmitted RF signal. Okay, normally the antenna here is around 10 feet. Okay. Then this is the microphone is the input of the frequency, and the antenna is the output frequency for the transmitter. For the microphone part, the resistor here is to control the current from the input, the voltage 9 volt, to control the current for the signal. And this capacitor actually functions as a DC blocking. What is DC blocking? DC blocking actually is just like when the frequency is high, the impedance is low. So when the frequency is nearly zero, impedance is nearly infinite. So means that the capacitor is for DC blocking and let the AC pass through. So when the frequency of AC is high, means the impedance of AC is low. Okay, and normally the capacitor for this two is for filter the noise part. Okay, this is the transmitter part. Next, okay, now I will proceed with the second receiver circuit. Okay, as usual, this is the PCB that we make for the current progress. From here, actually this is the receiver circuit. This is the antenna to receive the RF signal from the transmitter circuit just now. Okay, this is the tuner circuit, which from here actually we can determine the selectivity and sensitivity from the RF signal just now, the transmitter circuit. Okay, this resistor actually to detect the impact of the gain and the input impedance, just as a feedback. This circuit actually using 3 transistors, where these two is function as to get the high gain and the high input impedance. So from here actually, the third transistor actually got 2 functions, which to demodulate the RF signal into the signal that produced for the speaker, and to amplify the signal so that the speaker can produce analog signal. Okay. These two capacitors as usual to filter the noise. And I think next I will pass to Kelvin for the following presentation. Thank you.
Hello, thank you Tan just now for introducing, and before that I would like to introduce myself. My name is Kelvin. So here I will give you the conclusion throughout the venture for our project, which is the AM transmitter itself. So from the venture itself, we have learned the basic of AM itself, not even about the theory itself, but we have managed to do the model of the AM transmitter itself. So from the venture itself also, we managed to know the function of its parts and which component that may vary the result from the signal that we're going to receive before we get the output, the desired output from our circuit. So, okay, here last but not least, throughout the whole venture, we managed to achieve our goal, which is to build up the circuit of the AM transmitter and then to test its capabilities in terms of range and the stability that when we get the desired output from the circuit itself. Next, and here is the few reference that we use throughout the venture itself, which is from the internet and some of the modules and the journal. And here, as you can see from here, which is amplitude modulation retrieved from April 2006 from CA. And the next one is from the Wikipedia, which is about the amplitude modulation. And the third one also the Wikipedia contribution, which is about the medium wave, and the free encyclopedia from the Wikipedia also. Thank you.